Okay, good morning, Math 8. Today's Tuesday, April 28th, 2020. So today is going to be Regents Exam Practice Polynomials. Okay, so this is 8th grade material, but it's only doing things that you need for your Regents next year. This way you go in strong, no gaps, and you're a little ahead of the game instead of behind. So take these very seriously so you go into 9th grade feeling confident with your math. You don't want to go in with gaps. It'll overwhelm you in high school. Okay, so we did the subtracting, we did the adding, but on the Regents, this is how it would look. This should be printed out. If not, if you have your notebook, pause and write it all down. Okay, all right, so you're back. So now we're going to do number 1. So it's telling you, it gives you one polynomial, which is a trinomial, and another trinomial, and it says then do a minus b. What would that equal? A minus b. So you're doing this one, take away that one. Okay, so let's write them in the parentheses. So here's the first one. Once they give you the polynomials and they're telling you to add or subtract them, put them in parentheses first. And you're going to subtract the b. So the b is negative 2x squared minus 6x plus 7. Pause and make sure you catch up. Okay, so you just did problems like this yesterday and last week. So I want you to pause it and do the subtraction and then see if you can find the answer. Okay, you're back. So you put a 1 here, and this is a negative 1, correct? This doesn't change it, so you just rewrite it as 3x squared plus 5x minus 6. This is a negative 1, so you have to distribute. So negative 1 times negative 2x squared is positive 2x squared. Negative 1 times negative 6 is positive 6x. Negative 1 times 7 is negative 7. Then you combine like terms, so you get this one and that one. That gives you 5x squared. I'm just going to click that, okay? The 5x plus the 6x, which is 11x. So plus 11x. And then you have negative 6 and negative 7, which is negative 13. And then you find that answer, which is number 2. Okay? So now you can do Regents problems. Okay, number 2. This one is distributing a 3 in front. You know how to do that. And then there's a negative 1 in the second. So you distribute the 3 here and here and put a negative 1. So pause and do the problem. Okay, you're back. So I'm going to put the negative 1 there. So that's 3 times x squared is 3x squared. 3 times negative 1 is negative 3. Negative 1 times x squared is negative x squared. Negative 1 times negative 7x is positive 7x. Negative 1 times 10 is negative 10. I'm just going to put a 1 in here and combine like terms. Okay, so you're going to add the 3x squared and the negative 1x squared. If you haven't done it, pause and do it now. And you get 2x squared. Then there's no other x, so you just put plus 7x. And then these two add together. And that gives you negative 13. So you look for 2x squared plus 7x minus 13. And that's answer 2. Okay. All right, so we discussed these. Let's see if you can get this answer. So number 3. It says an expression of the 5th degree is 5, is written with a leading coefficient of 7 and a constant of 6. See if you can pick the answer that would satisfy that. Think about what the degree is. Think about what the leading coefficient would be and the constant. Pause and see if you can pick the answer. Okay, you're back. So the degree is the highest exponent value. So let's look at all the degrees. This one has a degree of 5. This one has a degree of 6. This one has a degree of 7. And this one has a degree of 5. They wanted 5, right? 5th degree. So this one's no good, and that one's no good. Now we have a 50-50 chance. Next, the leading coefficient is 7. Well, this one has a leading coefficient of 6, and that one has a leading coefficient of 7. It can't be this one, because the leading coefficient is the one that comes first. And just to double check ourselves, lastly, the constant of 6, that's the number by itself. It's constant. Your answer here would be 4. Okay. So, and make sure you complete the classwork. The classwork aren't Regents problems, but it's ones like these. And good luck. Have a great day.